Welcome to differentiation using the product rule. Just a reminder, as we've looked at in the other videos, the reason we differentiate is it finds the gradient of a tangent to a curve at a particular point. So the rule for differentiation using the product rule, if we're given y equals u times v, where u is one function and v is a second function, then y dash is equal to u times v dash, that is the derivative of v, plus v times u dash, that is the derivative of u. Look at some examples. So we're going to differentiate x squared, that's one function, times 4x minus 5 to the power of 4, that's a second function. And we're going to also differentiate 2x plus 1 to the power of 3, that's one function, and 5x minus 1 to the power of second, that's a second function. So what we're going to do is off to the side, rather than getting messy all inside our equation, is that we're going to let u equal to x squared and u dash equal to 2x, and v equal to 4x minus 5 to the 4. And if we differentiate that using, from our last video, the chain rule, you bring the 4 down the front, multiply by the differential inside, so 4 4s make 16. Rewrite the function and lower the power by 1. That's why we've got to the power of 3. So therefore, using our y dash equals u v dash plus v u dash, and substituting in what we've had up in the top right, that gives us x squared times 16 outside of 4x minus 5 cubed plus 4x minus 5 to the 4 lots of 2x. Now, on most occasions, that would be acceptable to leave it like that if it was just asking you to differentiate. But we are going to look at how to factorise, because this will become important with later questions and harder applications. So in that line, you will notice that we've got a 2 and a 16, so the common factor there is 2. We've got an x squared and an x, so that's how we get the 2x out the front. The highest bracket, or the largest power of bracket that we can actually take, is a power of 3. So that's why we take 4x minus 5 to the power of 3. That leaves us, in that first term, we've got the 8 and the x left. And in the second one, we've just got one of those brackets left, which is 4x minus 5. And then you collect like terms, and that's how we get the final line, the solution. Let's have a go at one with two lots of powers. So we'll have to use the chain rule twice. So you let u equal 2x plus 1 cubed. Bring the 3 down the front, multiply by the differential inside, which is 2. So 3 2s are 6, and lower that power by 1. With the second one, bring the power down the front, which is the 7, times by the differential inside, which is the 5. And 7 5s are 35. Make sure you lower that power by 1. So once again, our rule, uv dash plus vu dash. So substituting in from the what we got up the top right, and then we're going to have a go at taking out common factors. So in this case, our numbers are 35 and 6, so there's no common factor there. So we're going to leave them, and they'll go inside the final bracket. We're going to take the highest power of 2x plus 1 that we can, which is the 2, so it's 2x plus 1 squared, and the highest power of the 5x minus 1 bracket that's possible to take out, which is the 6. That leaves us inside the bracket, the final bracket, the 35 and 1 of the 2x plus 1, the leftover, and the 6 and the leftover 5x minus 1 bracket. So you expand that inside that bracket, and then finally you collect like terms inside that final bracket. So 70x plus 30x is 100x, and 35 minus 6 is 29. Thank you.